Hello and welcome to one more video on discrete random variables. I promise this will be the last video I do on this, and there is a reason I'm doing this is because the next video I'm going to use this example, so I want you to know what I'm talking about when I do the next one. And I'm going to talk about a little bit more about how this expected value works, the expected payout. Okay, so this example is actually in your book. Okay, if you're in my class. So what happens is this is an insurance company. Okay, they pay out money if somebody dies, if somebody gets disability, or they don't give anything out if if neither happens. Let's say this per year. Okay, so they have actuaries that run these statistics. Okay, so they know that for every 1,000 people, one person might die per year. Okay, about one person in the long run. Okay, two people out of those 1,000, two people might get disability. They might get disabled, and 997 of them will be fine. Nothing will happen. They won't have to pay them anything. Okay, so if you look, you kind of split this up and say, okay, out of these 1,000 people, 997 are going to get zero. Two of them will get $5,000, and one of them will get $10,000. Okay, so you know the formula. The formula is 0 times 997 divided by 1,000 plus 5,000 times 2 over 1,000, not 10,000. That's 1,000 plus 10,000 times 1 over 1,000. I'm going to show you how to do this on your calculator today too. Now the standard deviation, to find the standard deviation, we usually have to go through the variance first. Okay, you have to go through the variance first. So that's going to be 0 minus whatever we find up here squared times 997 over 1,000 plus 5,000 minus what we find minus the mean of these money paid out times 2 over 1,000 plus 1,000 minus whatever we find up here squared times 1 over 1,000. So let's talk about this logically. Okay, so the expected payout is actually the expected payout per person. It's expected payout per person, and the reason, and I'll show you why everybody gets confused, because technically, let's look at how much money they're going to give out per year. Okay, how much money are they actually going to give out? If two people get $5,000 and one person gets $10,000, aren't they going to pay out $20,000 per year? To how many people right now? To 3 people. Okay, that's reality. That's what's going to actually happen. But we don't look at it that way. We want it to be per person. How much per person? So it's 1 out of 1,000, 2 out of 1,000, 997 out of 1,000. So I'm assuming that it's for every 1,000 people. So I'm going to say I need to split this 20,000 into 1,000 equal monies. I want to spend 20,000 divide 20,000 into 1,000. Okay, and we could just knock 3 zeros off, so that'll be 20 divided by 1, so it'll be $20 per person. Okay, that's how much they have. That's how much they're expected to get a payout. Okay, all right. So let's go ahead and do this in your calculator. Okay, I'm gonna show you how to do this in the calculator, which I just learned today. Actually, never knew how to do this before. Okay, so we're gonna go ahead and find both of them. So let me just cover this stuff up for now. So what I did was I went and put all of my random variables in list 1. I put all my probabilities in list 2. 0.997 is just 997 over 1,000. That's what I did. I just put 2 divided by 1,000. It turned into a decimal. Okay, so just like we found the mean before, we hit, let's clear out of this. We go stat, calc, edit. And now what I want to do is I want to put list 1 comma list 2. If you don't do that, it's just going to find list 1. List 1, list 2. Hopefully this works. Okay, look. This X bar should really be a mu. Okay, the calculator doesn't realize that. So they're expected to pay out 20 per person. 20 per person. $20 per person. Okay, and you're going to see why this is very, very important for the people who work for this company, because this is going to be how they make their profits. So I'll put a 20 here, a 20 here, and a 20 here. Okay, and then they do get this right here. See this 386? Okay, that's the standard deviation. That's going to be 3. Let me write the notation. I showed you this notation on another video, so it also can be written like this. Okay, so that's 386.78. Okay, that's the answer to that. Okay, so that's a lot of variability. So this company, you have to be careful. Okay, because if it could go to the left, and you could lose money, or it could go to the right, and this how much do they have to pay per person? Because if it goes to the left, that would be good for them. The bigger this number is, it's the worse for them, right? Because 386. And what this 386 means is there's a chance that maybe more people would die in that year. So if 2 people died, that would be bad for them because they'd have to give 20,000. That's why this variability is so high. Okay? So if you found this number, this is what it would be. It'd be that squared. And to get from the variance to the standard deviation, you just take the square root of this. In games of gambling, the fun games, when you do gambling, fun games have a high variance, or high standard deviation. It means the same thing. Okay? Because it's that risk reward. If you play a game, the bigger this is, okay, the more of a chance that you could win a lot of money. Or it's the more chance that you could lose a lot of money. Okay? Alright, so let's look at this $20 real quick, and let's just think about this logically. So if they're looking, they're going to give $20,000 to 3 people. But what they want to do is, they don't know who these 3 people are, so they want to get money from every single person. Okay, so everybody has to pay. All these 1,000 people, whether there's 2,000, 3,000, everybody has to pay. Okay, so what happens here is the company knows how much they're going to have to pay the people. Okay, they already know how much money they're going to lose. The company knows how much money they're going to lose per person. Okay. Okay, because if it's money they're paying, they're actually losing that money. Nobody gave them money. You see that? Nobody gave them any money yet. This is the company. This is the company right here. It's very important that you get that concept, okay? This is how much they have to pay out. They haven't gotten anything in yet. But that's how they set their premiums. Because if they know they have to pay 20 per person, they'll go ahead and say, okay, to buy into this policy, we want $50. That's why insurance companies always make money. Okay? They always make money. I mean, of course, they need more people to lower the risk, but they make money because they know with these statistics that they know their risk. So the risk is, $20 per person. Yeah, it could be worse because of the standard deviation. But if you get a lot of people and you make people pay $50 per policy, how much money are they going to make? how much money will they make per policy? They'll make $30 per policy. Okay? So it's kind of important that you could kind of get around these things, okay? So I'm going to use this example on the next video to talking about adding means, because this is per person. So this is how much they have to pay out per person. So what if 2 people buy a policy? Okay? So X1 would be the first person, X2 would be the second person. Okay, and we're going to get into that. So if they have to pay 20 for the first person, how much do they have to pay out on average for the second person? $20. We're going to get into how to add those and how to add the standard deviations, okay? Alright, so thanks for watching.